share it one more time. Okay, so now it's okay, yeah? Right. Okay, so we have two functions of xt and yt, which are said to be added to give a zt. So by these two functions, we are requested to find, or we are requested to write the trigonometric equations for xt, yt, and zt. So basically, this is what we have done before. We have to write the xt and yt in their time-based equation. Okay, knowing that this is a sinusoidal wave, and I think it should not be a big problem for you to write the equations of xt and yt, and we can refer to the solution to this. Okay, because this is a sinusoidal wave, yeah, normal sinusoidal wave. Maybe we have a shifting a bit, yeah, and reversal a bit, so nothing much to be worried here. But after all, let's have a look at the solutions for this. Okay, let's have a look at the solutions here. Okay, I think I don't have solution for this. I'm very sorry. I don't think I don't have solution for this slide. I apologize. Yeah, I don't think I prepared a solution for this example. Yeah, no solution for that. Yeah, my solution is only up to this example just now. I'm very sorry. But after all, this is just similar to what we have done before. Okay, in which for this particular case, we need to write the xt and yt with respect to its trigonometric equation. But so, for example, if we base on this yt, we can write that yt is a negative sine function, yeah, negative sine function with the amplitude of 9 and time or period of 10 milliseconds. And if you base on the xt function, we know that the xt function is basically a sine wave in which the peak value or peak to peak value is equals to 16. Peak to peak value 14 plus 2 will be 16, and that's a shifting of 6 value. Yeah, shifting of 6 value or 6 unit upward. So based on that, you can write the xt with regard to that information. Yeah, hopefully it's not be a big problem for you then.
Doctor, the one in the right, isn't it cosine instead of negative sign?
Yeah, it should be negative sign, right? It should be negative sign, yeah?
Yeah, isn't negative sign is cosine, or is it different wave?
Negative sign will be a cosine plus something, plus 90 or minus 90.
Minus 90, but...
yeah, it should be plus 90, sorry. It should be plus 90. Should be plus 90, yeah?
Okay.
Yeah, right. So I think we have done this before from the previous example. You must be able to write the xt and yt in its time-based transformation, time-based equation. And after then, what you have to do is that you have to write the complex exponential Fourier series for this zt, which is the addition of xt and yt. And so after that, you have to draw the spectrum. Okay, so this is, I can see, a repetition from what we have done, I mean, from the examples that we have done before. But still, if you got a problem with this example, you can always come back to me then, yeah? Okay, let's proceed with this slide number 7. Okay, so this is the last part of lecture 7, which is a Fourier series transformation. So if we have a complex exponential type of Fourier series, let's say we have xt, which is a summation of n from negative infinite to positive infinite of cn. Okay, this is in third form, a complex exponential type of Fourier series. So now, if we say that xt is said to be amplitude transform, or xt is said to experience an amplitude transformation to a new functions of yt, in which we can relate the yt and xt by this equation. Yeah, xt is the original functions with this Fourier series equation in complex form, and the yt is related to xt by this shifting of amplitude of b and scaling of amplitude by a. So we have yt equals to a of xt plus b. So now, sorry. So now we can say that for yt function, its Fourier coefficients can be obtained by this relationship. By this relationship, whereby the C naught of yt, or the C naught of y will be equals to a of C naught x plus b, and the Cn of y will be a of Cn x. Okay, I repeat again. We know that the xt, which is written to be in this form, so xt by right has its own Fourier coefficients. Yeah, we have the C naught, we have the Cn, correct? Yeah, we have the C naught and we have the Cn for xt itself. But when we have a new functions of yt, where yt and xt are related by these equations of constant of scaling constant a and shifting constant b, so we can then relate the new Fourier coefficients of yt by these equations, where we have C naught y will be a of C naught x plus b, and Cny will be a of Cnx. Okay, so that should be a Fourier coefficients obtained for a function which is said to experience a transformation, of transformation. Okay, so to understand this further, let's have a look at this example here. This example. So these examples, we are given sawtooth functions. The sawtooth functions, we have x naught and t naught as the amplitude and period of the xt respectively, where we are given that x naught equals to 2 as the amplitude, and the period of t naught equals to 2 milliseconds, 2 milliseconds. Okay, so we need to write the Fourier series for xt in complex exponential form up to the second harmonics. Okay, so that's the first start. We need to write the Fourier series for xt in complex exponential form up to second harmonics. And afterwards, we are given that there is a transformation of xt in which the new functions of yt is equals to 2xt plus 5. Okay, there is a new functions of yt in which yt and xt are interrelated by these equations, where we have yt equals to 2xt plus 5, where shifting constant is 5 and scaling constant is 2. Okay, so based on this information, we need to write the Fourier series for yt in complex exponential form up to second harmonics. Okay, yeah, so hopefully you understand about this question. So first of all, you need to obtain the Fourier series for xt. Yeah, Fourier series in a complex exponential form. Okay, so for this, you have to refer to the table. Yeah, we have to refer to the table. So let's refer to the table. I'm now going back to the table of this. Okay, let's have a look at this table. Okay, which is a sawtooth functions here. Yeah, sawtooth functions, signal number 2. Okay, number 2, we are referring to this now, where for this sawtooth function, the C naught is given by x naught over 2, and the Cn is given by j x naught over 2 pi n. So this is given from table. So we're going to use the C naught and Cn from this table to the solution. So let's have a look at the solution for this example. Okay. So from the table just now, table V3, we can see that the C naught, which is equals to x naught over 2, the value shall be equals to 2 over 2, yeah, because the amplitude is 2, so we have 1 as a C naught. Whereas for the Cn, you're going to have j of x0 over 2 pi n, and since x0 equals to 2, the Cn shall be j over 2 pi n. Okay, so we have obtained the C0 and Cn for the yxt functions, yeah, which is obtained from table. Okay, so based on the obtained x0, C0 and Cn, we can then write the Fourier series equation for xt in trigonometric form. So that should be the equation, summation of n from negative infinite to positive infinite of Cn exponential j(n) omega naught t. So we can write it as follows: j over 2 pi n exponential jn, and omega naught equals to 2 pi over t. Yeah. So you know that t is 2 milliseconds. So 2 divided by 2 milliseconds will give us 1000 pi. Yeah, omega naught equals to 2 pi divided by t. Yeah, 2 pi divided by t. So 2 pi over 2 milliseconds, we're going to get 1000 pi as the omega naught. Okay. And C naught is given here. Yeah, we write C naught outside. Yeah, that's why for these summations, I exclude n equals to 0. Yeah, so this summation is only valid for all n except n equals to 0, because for n equals to 0, which is C naught, it is here. 1. Yeah. Okay, so from now, we can then write the xt in up to the second harmonics, yeah, up to second harmonics, which is up to n equals to 2, starting from n negative 2, negative 1, 0, 1, and 2. So we're going to have this form here. Okay, so we have a negative j over 2 pi of 2. Yeah, this is for n of negative 2 value, n of negative 2. Okay, the second term here is for n equals to negative 1. So this is for n0, which is 1. This is for n equals to positive 1. And down here is for n equals to 2. Okay, so we have expanded. Yeah, we have expanded the xt up to second harmonic, starting from negative 2 up to positive 2 value. Okay, then, hopefully you understand, yeah? Okay, then we can write that, we know that j equals to exponential j pi over 2. So we can then write j as in terms of phase. So that we're going to have 1 over 4 pi exponential negative j of 2000 pi t plus pi over 2 for the first term here. And the rest will follows. So that should be n of negative 1. Okay, this is 1 for n0. This is for n equals to a positive 1. And that should be n equals to 2. Okay, that should be the case. Yeah. So what we did here is that we transform all the j terms into phase. Okay, so we have done with the xt. So what we have here is the xt, or the Fourier series of xt in a complex exponential form. We have done it. Okay, now the second part of the question is to find the Fourier series equation for yt. And we know that yt and xt are interrelated by these equations of amplitude transformation to xt plus 5. Okay, so by using this information, that the C naught of y will be simply 2 C naught x plus 5. Yeah, this is a plus b. Remember from the slide just now, a plus b. So a stands for the scaling constant, b stands for the shifting constant. So C naught y will be simply 2 times C naught x. Remember, what is C naught x? C naught x equals to 1. We go back to this. We know that C naught x equals to 1, yeah? Yeah, this is C naught x, then this is Cn x. So that will be used here. So we have then the C naught y equals to 7. But the Cny will be simply a of Cnx, or 2 of Cnx, because the constant of scaling is 2. So we have 2 of Cnx. So from this information, we have now obtained the new Fourier coefficients for yt. Okay. So we're going to substitute this information of C naught y and C naught y into these equations just now. So we're going to have, for n equals to negative 2, you're going to have 2 over 4 pi. Yeah, because before this we have 1 over 4 pi, right? But when we have this transformation, so all the Cn need to be multiplied by 2. So we have 2 over 4 pi. The same things applied for the C negative 1, which is 2 over 2 pi. Okay, 2 over 2 pi, this is for c of negative 1. For c naught y, we're going to have 7. Before this is 1, right? Before this is 1 for xt, but from the transformation, is and c naught y is 7, so we have 7 here for the c naught y. And the rest will follows, in which for c and y, yeah, going to have 2 over 2 pi and 2 over 4 pi. This is for n equals to 1. This is for n equals to 2. Okay. So,
Doctor, don't we need to simplify more?
if you give the answer up to this stage, so it should be okay. Yeah, it's acceptable. Because the question asks you to write the yt or xt in terms of complex exponential type of Fourier series. So if you get up to this stage, so it should be good enough. Yeah. Okay. Is that clear on this example on the signal which experiences an amplitude transformation? Is that clear? Okay, the last 2 pages from lecture, you can get it from the Google Classroom, in the attachment on lecture 7. Okay, right, so hopefully you are clear about these examples here. Okay, let me have a look. Is there any more slides to do to settle? Okay, I think that's all for lecture 7. So for next week's lecture, we're going to proceed with this topic. Yeah, so our emphasis next week will be on the Parseval's theorem. So this will be our emphasis for our lecture on Sunday next week. Okay. So as promised yesterday, for today's lecture, we're going to proceed with the tutorial questions, right? Okay, tutorial questions. So now it's tutorial question, tutorial session. So you have any problems related to tutorial 1? But before that, is there any questions on lecture 7 so far? No? Okay, so if there is no questions, I think we can now proceed with we can now proceed with the tutorial 1. Okay, is there any question for tutorial 1?
Any question in the whole tutorial, Doctor?
The whole question?
A question on the tutorial, or are we going to start question by question, Doctor?
I think you don't have much time to cover all of these, so we can just simply go to
then question 4.
questions 4. Okay, the rest of you, how about question 1, question 2?
No, it's question 3. Sorry, Doctor. Question 3.
Okay, never mind. We just ask the rest if you express any problem with question 1 and 2. So basically for question 1, it's nothing much. It's just a operation of signal, right? Shifting of time, scaling of time, reversal of time, and then we have amplitude transformations, yeah? Scaling, reversal, and shifting. So I think there's nothing much to be worried on this question 1. Hopefully you can understand that. For question 2, it's basically on the functions, basic functions which experience a transformation. Yeah, so I think we have done the examples related to this in our lecture. So again, I hope that you can try to solve this on your own. Yeah, nothing much to be worried there. Okay. Any question on this? Clear for 1 and 2. Okay. How about the rest? So I assume that you are clear about these question 1 and 2. Yeah. So if there's no question, let us proceed with question T, question number 3. Okay, question number 3. What question that you want to ask then?
I did not understand it. We already solved the first, right, the mathematical expression in a previous slide, but I did not understand the solution. How did we? It's a unit step function, but I did not understand how we wrote it in the class.
Is it for this function? Is it xt?
Yes.
Uh,
The only
um,
difference it's in the class class example it was till 5. This example is till 4. That's the only
okay,
difference.
all right. So the same question that we have in the class, right? So basically for xt, what you have to do is that you have to divide this xt into its respective region. Yeah, we have region number 1, okay, up to 0 to 1. Okay, let me see if I can sketch somewhere here using the Jamboard. Let me see, yeah. Whiteboard. Sorry. Can you view the Jamboard here from my PC?
What, doctor?
Can you view the whiteboard from my PC? Let me try again.
No,
Yeah.
no, no. We can.
Okay. Let me see. Can you view this whiteboard?
Yes.
Okay. So let's have a look on this problem. Okay. So we have. Sorry, I'm using my bare hand to sketch this. Yeah. Is it clearly shown here, right?
Yes, yes, doctor.
Okay. So this is 1. This is 2. This is 3. And this is 4. Okay, so you have to divide into the region, right? This is the region number 1. Sorry, yeah, it's just a bare hand. I just use a mouse. Sorry for that. But hopefully you can understand that clearly, yeah? Okay, this is region number 1, region number 2, region number 3, region number 4. Okay. So we leave that for region number 1. Okay, for region number 1, so we have the equations for region number 1 will be ut, okay, minus ut minus 1. Am I right?
Okay.
Okay, for region number 4 should be the same, ut minus 3 minus ut minus 4. Okay, how about region number 2 here? So region number 2, okay, so we are supposed to get a line like this, right? Okay, this is 1 and this is 2. Okay, so what you have to do now is that you have to know what should be the straight line related to this slope. Yeah, so for this slope, it is equals to, the slope should be equals to
1.
negative 1. Negative 1, correct? Okay, so the equations for this straight line will be y minus 0 to be equals to negative 1. Sorry, I need to use a duster. Okay, sorry for that. I have this limitation, sorry for that, yeah? This is the best I can do. Okay. Okay, y minus 0, this I'm choosing this point here, down here, shall be equals to negative 1, sorry, negative 1 of t minus 2. Okay, so we should have y shall be equals to negative 3 plus 2. So that should be the equation for that line, for this line, yeah? For region number 2, that should be the equation. But if we base on this equation, it will be extended from negative infinite to positive infinite. But our interest will be only on these regions, yeah, between 1 and 2. So what we have to do is that we have to write these equations of straight line, which is negative t plus 2, okay, and you have to multiply this with the step functions from 1 to 2, which is ut minus 1, okay, minus ut minus 2. Okay, that should be the case. Okay. All right. That should be for origin number 2.
Hello, Victor?
Hello. Yeah.
Yeah. We found the slope first, right? After we found the slope,
yeah.
How did you get t minus 2?
Which one? Is it this one?
Yeah.
Oh, this is from the straight line equation. You have to go back to your mathematics in secondary school. Okay. You go back to secondary school mathematics, so hopefully you can find the answer from that. Yeah. Okay. Right. So hopefully you are clear about the solutions here. So the same will goes for region number 3 and region number 4. Okay. All right. Okay. Good. So I think it's clear. Yeah.
Yes, doctor.
Okay, good. Thank you very much. So let us proceed. If you have any questions from the students then. Tutorial again. Okay. Any more questions related to tutorial number 1? No question at all? Have you tried tutorial questions before you enter the class today?
I did not do all of them. I did some of them. The first bit,
okay,
because it's easy. The first bit,
so I think it's good if you can try the tutorial questions before we start the session, yeah. Because that's how you know what are the things that we don't understand in tutorial. Because frankly speaking, I don't have exact solution for this tutorial, like what we have in the lecture notes. So I cannot provide you with the solutions straight away. Question 5 from Chong Sin Swan, yeah? Okay, question 5. I'm referring to question 5, which is asked by your friend. Question 5, okay, this is the one. All right, question 4 should be okay, yeah? So you can try this. If you got problem, please get back to me. Okay, for question 5, we are given two discrete system, the G and H. Okay, and then we are given that, Xn is in terms of impulse function in discrete time system, yeah, basically discrete time system. We have 1, 2, 3, 4 impulse function for the Xn. Okay, and Xn is the input to the two systems G and H with respective output value. Okay, and then continuously, the second page here, we have the G and H output is said to be multiplied, produce the Sn, okay, and the Sn, which is a multiplication of A and B output, will be multiplied with the Rn. Rn is given here, and it will give the Zn. The question is illustrate graphically signal of Xn. Okay, that's the first question. Now, yeah, illustrate the Xn. So Xn is given by these equations or these terms here. So what should be the Xn? Yeah, what should be the Xn? So let's have a look at the solutions for these questions. Okay, I have to use a Jamboard. Okay. So we have 4 impulses there. Yeah, if you can refer to the question, we have 4 impulses. If we can sketch it, we can have look like this. Okay, this is your n. So we have at n equals to 0, we have at n equals to 1, we have at n equals to 2, okay, and finally we have at n equals to 3, and it's given that the amplitude is 1 for, okay, this is 1 for n equals to 0, n equals to 1, we have half, okay, we have half for that. For 1 over 2, sorry, for 2 we have 1 over 4. Okay, we have 1 over 4. And for 3 we have 1 over 8. Okay, so that should be the answer for part 1, which is to sketch the xn. Okay, is that clear on this? Yeah, so basically this is based on the given xn. So from the equation of xn, you have to sketch it accordingly. Okay, is that clear on this? Okay, yeah, hopefully you are clear about this. So I'm going to clear this. So I'm now going to proceed with this number 2 question. Analyze both signals at both point A and B and sketch the SN signal. So you can refer to your tutorial handout. So A and B is the output of G and H. Yeah, output of G and H. And from the output of G and H, we have initially okay, I think I have to resketch for you then. Easier then. Sorry, yeah. I have to redo it just to make it clear for you. This is 0, this is 1, this is 2, and this is 3. Okay, so we have 1. Okay, this is half. This is 1, yeah. This is 1 over 4. This is 1 over 8. Okay, so it's said to be the operations involved is shifting. Okay, you can refer to the questions. Yeah, it is x of n plus 2. Okay, we start with the shifting first. Okay. So all of it will shifted 2 units to the left. So it will start at okay, will be at -2. Okay, we're going to have at -1. We're going to have at 0, and we're going to have it at +1. Okay, all of them will be shifted. So we're going to have 1. We're going to have half. Okay. We're going to have 1 over 4. And then we have 1 over 8. Okay, that should be the results of shifting. Okay, shifting by 2 units to the left. And afterwards, we have a reversal. Yeah, reversal of the xn. We'll have x of -n plus 2. Yeah, it's a reversal of time. Okay, so it means that everything here will be shifted, will be reversed. Yeah, negative will go to positive and positive will go to negative. So as a result, your signals will now reverse the -1. Okay, and zeros will be no change. Yeah, we have 1 and we have 2. Okay, so we have this will be 1 over 8. Okay, 1 over 8. The 0 will be 1 over 4. Sorry, yeah. 4. Here will be 1 over 2. Okay, and here will be 1. So hopefully you understand, yeah? I don't have to write the value for both for these impulses. It's just simply a reversal. 1 will go to -1 and -2 will go to +2. I just write 1 here. Okay, that should be 1, the amplitude for this. Okay, and afterwards we have a square of the amplitude. Okay, we have x square of those things. So we're going to have -n +2. Okay, so we have no changes on time, -1, we have 0, okay, so we have 1, and we have 2 here. But the amplitude now will be a square of the value. So we have this will be 1 over 64, okay, 1 over 64. Okay, here will be 1 over 16. Okay, 1 over 16.
Doctor,
Yeah.
was it? I think it's gonna be smaller.
Which one?
The amplitude. Yeah, the numbers are right, but the drawing, I mean, it should be smaller.
Which one smaller?
1 over 46, because 1 over 8 is bigger than 1 over 46.
1 over
64,
8.
sorry. Well, 1 over 8 is bigger than 64.
Okay, so square
I
of
think
this.
it.
1 over 64. 1 over, this is 1 over, sorry, this is 1 over 16. Okay, and here will be 1 over, okay, sorry, it should be bigger than this. So this will be 1 over 4. Okay, 1 over 4. Okay, and here will be 1. It should be bigger lah. Okay, this will be 1. Okay, is that correct for this output of system G? Okay, yeah?
Correct.
Okay, you got it, yeah? Hopefully you're clear about this, yeah? Sorry, my my drawing is very bad, yeah? Because I'm using mouse, but hopefully you can understand the story behind these solutions. Okay, is it okay then? Chong Sin Swan, is it okay? All right. Thank you. Right. So now B. To find next one is to output of B. Yeah. Just now is A. Yeah. Before is A. So now is B. So please record this. Yeah. I'm going to clear this frame. Yeah. I'm going to write the B now. The output of H system. Okay. You can refer to your tutorial questions. So there are two functions there basically where we have 2xn and xn plus 1. So I need to redraw the xn now. So the xn basically same as before. Okay, this is 1. This will be 1 over 2. 1 over 2. Okay, this will be 1 over 4. Okay. And this will be 1 over 8. Okay. Right. So we have it as 0 now. This is 1, this is 2, and this is 3. Okay, notice that the output of system H consists of two terms, yeah? Which is 2xn and xn minus 1. So I'm going to do it one by one and then need to add them together. So go for the first one, which is 2 of xn, which is a amplitude scaling, yeah, 2 of xn. So basically there should be no changes on the n value. Okay, the changes should be only on the amplitude. So that should be 2, the new amplitude, 2. Here will be 1. Okay, sorry, it's not up to the scale, but you hopefully understand. So this is half. Okay, and this will be 1 over 4. Okay, so that should be 0, that should be 1, that should be 2, and that should be 3. All right, good. And then for the second part of this, we have xn plus 1. Okay, xn plus 1. Okay, so it's a shifting of n by 1 units to the left. Alright, so when we shift it 1 units to the left, n or minus. Sorry, it's minus. I apologize, it should be minus, yeah? I'm going to rub this, sorry. Okay, it should be minus, yeah? Sorry. Not plus, it should be minus. Okay, so minus, we're going to shift it to the right. Okay, shift it to the right. So 0 will be shift to 1. And following that, we're going to have shift from 3 to 4. So we're going to start it at 1, 1. We're going to have 2. We have 3. And we're going to have 4. Okay, so 1 should be there. Remember, no changes on the amplitude, yeah? We just change the position of the impulses. Okay, this is 1 over 2. 1 over 4. And 1 over 8 should be here. Okay, so that should be your x, 2xn and xn minus 1. So we have to add them together because that should be the output of system H, addition of 2xn and xn minus 1. So we add them together. Okay, so when we add them together, what we're going to have, we can have it here. Okay. Okay, so we're going to have 5 impulses from 0 up to 4. Yeah? Now we're going to have 5 impulses at 0, at 1, at 2, at 3, at 4, sorry, yeah, at 4, and so up to 4. Okay, so 0 will be 2, just a summation, yeah, summation of those. You have 2 here. Okay, you have 2, summation, because for 0 here is 0, nothing much. So it's 2 plus 0 will be 2. For 1, we're going to have 2 also, because 1 plus 1. Okay, we're going to have 2 for n equals to 1. For n equals to 2, we have 1. Okay, we have 1 for n equals to 2. N equals to 3, we have 1 over 4 plus 1 over 4. So that will give us 1 over 2. Okay, 1 over 2. And at n equals to 4, we only have a single impulse here. So we're going to have 1 over 8. Okay, so we have done with the output of the B. Sorry, output of the H. Yeah, output of the H, which is B. Yeah. Okay, so that should be the output at B point. And also we need to sketch the Sn signal. What is Sn signal? Sn is a multiplication of A and B. A and B, yeah? Multiplication of A and B. So if you can recall back, I'm going to rub this, yeah? Hopefully you're clear about this, yeah? Okay, hopefully you're clear about this. So I'm going to rub this this part. Okay, I'm going to rub this part here, sorry, yeah? Sorry guys, yeah? Very slow. Okay. Okay then. We now add the functions at output A that we have obtained before. Okay, so at output A, if we can rewrite it now. Sorry. So it should be at sorry, yeah. Okay. Okay, so this is at output A. So we have starting from -1, we have 0, we have 1, we have 2. Okay, so we have -1 is 1 over 64. Okay, 1 over 64. This will be 1 over 16. 1 over 16. Okay. Sorry, this will be 1 over 64, yeah? 1 over 64. 1 over 64. At 1, we have 1 over 4. Okay, this is 1 over 4. Okay, and at 2, we have 1. Okay, we have 1 here. Okay, so this is at output A, yeah? So I label this as A, at the output of A, and this is at the output of B. So in order to obtain the Sn, we need to multiply A and B. Yeah, so multiply between the two here, multiply A and B. Okay, so what you should get here? So from this multiplication, we know that the value will not be 0, only at 3 value of n, which are 0, 1, and 2, right? Because the rest is a multiplication with 0, yeah? So end up going to have the multiplication result will be at 0, then we have at 1, and we have at 2. Okay. So at 0, we have 2 multiplied with 1 over 16, which will give us 1 over 8. Okay, that should be 1 over 8. At 1, we have 2 multiplied with 1 over 4. We're going to have 1 over 2. And at n equals to 2, we have 1 multiplied with 1. Yeah, 1 multiplied with 1. Okay, so we're going to have what then? Yeah, so for this, you have, for n equals to 2, we have 1 multiplied with 1. So we're going to have 1. Okay, you have 1 there. Okay, so that should be the output of Sn. So what we're having here is the Sn. Okay, is that clear?
Yes, doctor. Now we need to multiply with Rn.
Correct. So we need to multiply with Rn now. Okay. So up to Sn, is there any questions? Hopefully you understand, yeah? So we managed to obtain the Sn now. Okay. All right. So I think for the multiplication with Rn, the next part, Rn is given. Impulses at 1 and 2 only. Okay. So multiply with Rn will give us the Zn. So what should be the Zn later on? Okay, so I need to clear the frame. So is it okay that can I clear the frame now? Okay, can I clear the frame now? Okay, yeah, so I clear the frame now, yeah? All right, thank you. Okay, so let me multiply these two functions. So the Rn is here given from the questions. This is the Rn at 1 and at 2, which is 1, and this is half. Oh, sorry, not up to skin. Sorry, that should be, I need to, okay, that should be okay. Okay, this is half, yeah? Okay, 1 and 2, 1 and half. Multiply with the Sn that we have obtained before, which is at 0, at 1, and at 2. Okay, in which if you can recall back, we're going to have this will be 1 over 8. This should be equals to half, and it should be equals to 1, yeah? Okay, so I write 1, this is 1 over 2, and this is 1 over 8. Okay, so when we multiply these two, this is your Rn, this is your Sn. So when multiply the two things here, you are going to have only two impulses, which is at 1 and 2, in which the answer for this will be half amplitude, and here will also be half amplitude. Yeah, so that should be half, and that should also be half. So what you have here is your Zn lah. So that should be your Zn. Okay, that should be the answer for part 3 of the questions. In which, in terms of the impulses, you can write that the Zn is delta function of n minus 1 with the amplitude of half, yeah, half of it. Okay, plus half of a delta function of n minus 2. Okay, that should be your Zn lah. Yeah, in terms of mathematics equation. Okay, that should be your Zn. Right. And number 4 of this question is determine whether the system is causal and stable. So if based on this Zn, the output is causal. It's causal because we don't have any future value. So the Zn is only referring to the past values. We have -1, -2. So the system is causal. And whether the system is stable or not, we have to compare the input and the output. So for the input, if we base on this question, we have the Xn, which consists of 4 impulses at 0, 1, 2, and 3 with the amplitude of 1, 1.1/2, 1/4, and 1/8, respectively. Yeah, that's for the input. Yeah, we have 4 impulses located at 0, 1, 2, and 3 with the amplitude of 1, 1/2, 1/4, and 1/8, respectively. For that input, your output is this, which is located at 1 and 2 with the amplitude of half and half for both. So we know that based on this, with the small amplitudes provided, the output will also be a small value, half and half. So which means that the system is stable. Yeah, the system is stable. Okay, that should be the answer for question 5. So hopefully by this limitation, you understand the solution for question 5, yeah? Okay, any more question? Can I solve question 4 for you then? Is it okay if I solve question 4 for you?
Yes, doctor. Yes.
Okay, thank you very much. Yeah, because we still have another half an hour. So I think it's good if we can solve question 4. Just to ensure that you really understand on question 4, yeah? Okay, so question 4, if we can base on this, if we can based on this equation, yeah, we have x1t, yeah. So x1t basically consists of 2 functions. If you can write for you, the first one is negative ut plus 1, in which if you sketch it, it should look like this. This is -1. Okay, this is negative ut plus 1. Yeah? If I can write for you, this is negative u t plus 1. Okay, plus 1. Yeah, sorry, this should be plus 1. Okay, plus 1. Yeah? Okay, and it is now added with another function, which is t plus 1 ut plus 1. So t plus 1, if I can rewrite here, t plus 1. Okay, ut plus 1. Okay then. So how this function should look like? Okay, so this is similar to what we have seen yesterday from the solutions of the examples that I gave to you. Okay, so by right, your function for this should look like this. Yeah, the solution should look like this. Okay, this is a ramp function which has shifted 1 unit to the left. So this is 1, this is 1. Okay, so supposedly your function should look like this. Okay, that should be the way, yeah. So sorry, it should intersect the vertical axis at 1, yeah. So that should be the function of t plus 1 and ut plus 1. Okay, so these 2 functions are said to be added. So if we add these 2 functions, what should be the case then? That should be the case. So if we add these 2 functions, you are supposed to get a function which should look like this. Okay, this is the vertical axis. Sorry, yeah. Sorry. Okay, vertical axis. Okay, so for this, you're going to have, okay, this is your step function, -1. Because of negative sign, because of negative amplitude, and we have a positive amplitude here, your signal will be shifted downwards, and you're going to have, that should be your signal. Yeah, so addition of these two will give us this. This is at -1. Okay, so the slope of this is 1, yeah? The slope of this straight line is 1, which follows the slope here. Okay, that should be the sketch for x1t. Okay, any question for that, for x1t? No?
No, I think it's clear, Doctor.
Okay, good. So let us proceed with x to t now, because it's requested from the question. Sketch the x to t. Okay, let's clear the frame. Okay. Okay, for x to t, we have again two terms. The first one is for the x to t. So we have t minus 1, ut minus 1. Okay. Okay, so basically that should be a ramp function, which is said to be shifted by 1 unit to the right. So you should have like this. This is 1. And remember the slope is 1, yeah? So okay, this is 1. Just to ensure that the slope is 1, yeah? Okay, next one, the second term is ut minus 1. Okay, ut minus 1. So it's a step function, which is said to be shifted by 1 units to the right. Okay, that should be the case. And after this one. Right, yeah? So that should be your step function, ut minus 1. So we need to add them together, this addition. So how this function should look like? So basically when we add these two functions together, okay, so you're going to have something like this, a straight line up to 1. And afterwards, you're going to have shift by 1 unit upward, and that should be a slope. Okay, that should be 1. Okay, so that should be your function of x to t. All right then. Is that clear on this? Okay. Hopefully you are clear. Yeah, we shift it. Yeah, we shift it due to the existence of the step functions of 1. So from this value of 0, we shift upward and have the straight line will now shifted at 1. Yeah, and t equals to 1. Okay, so that should be the x to t. So your task now is to add them together. So this is what not to add, it's to subtract. Sorry, it's to subtract. Yeah, because if we base on this diagram number 4, diagram for question 4 is a summation, although we're using the adder. But if we look at this diagram, it is yt basically is x1t minus, yeah, x1t. Yes.
Yeah, Doctor. In the question, it's saying the sum of xt, x1t, and the negative x2t.
So it's a subtraction basically. Yeah, x1t minus x2t. Yeah.
Yes, but
uh-uh.
in the first example, was it? Okay, I think it's my mistake. I read something wrong. Sorry.
All right. Okay, good. Yeah. So we have done with the x1t and x2t. So our task now is to add them together now. Okay, I'm going to clear the frame. So I need to re-sketch for both function. Yeah. So that should be your that should be your x1t. Sorry, yeah, not that nice my drawing. Okay, that's a -1. That should be -1 also. Okay, this is your x1t. Okay, and you minus it with the x2t. Okay, so the x2t is here. All right, so we have this is 1 and this is 1. Use subtraction, yeah? Okay, so you can imagine that when this function of x1t minus the x2t, so we can say that for the value of 1 or for the value of t bigger than 1, it will be 0. Yeah, for t of 1, for t bigger than 1, this subtraction will give us 0, yeah, because basically this slope and this slope are the same, or this line equation and this line equations are the same. So from 1 onwards, the value will be 0. So end up, what we're going to have, we are supposed to get, this should be the -1, that should be a +1. Okay, so that should be the axis, vertical axis. So we're going to have this line, okay, and you're going to have a straight line up to 1 and going back to 1, going back to 0, just like that. So this will be -1. So yeah, and this should be +1. Okay, so that should be the results of the subtraction between these two functions. Okay, is that understood for the subtraction of the two functions? Okay.
Doctor, the one in the YT x2t.
Yeah. Okay. This is the one.
Yeah, the positive one. When we subtract it, it's weird. I don't know how to. I don't understand it. How did we get that shape in the YT result?
Oh, is it for t bigger than 1? Is it?
Yes.
Okay. You see that this slope, right? This line and this line are the same. Am I right?
Yes.
Because,
so the result is 0.
Correct, because the line are the same, are having same equation. So if we subtract from t equals to 1 onwards, yeah, t equals to 1 onwards. So this one minus this one, we're going to have 0 straight away. Am I right?
Oh, okay. I got
right.
it.
Okay, good.
Yeah, okay, got it.
All right. So hopefully you're okay with this YT. So that should be a YT. So YT will be used in number 2, in which the YT is said to experience a differentiator. Okay, so I need to clear this frame now. Yeah, I need to clear this frame now. Okay. Okay, so I rewrite for you, resketch for you the YT that we have obtained. Okay. Okay, that should be the case. All right. So that should be -1. That should be +1. That should be -1, and that should be +1. Yeah. Okay. So this function YT is said to go through the differentiator, which is d over dt. Yeah, d over dt, differentiator. So what should be the results of this differentiation then? Okay, this is what we have learned in lecture number 2, sorry. Yeah, lecture number 2. Okay, if you can recall back, that what we have here, this is -1, this is +1, yeah? Okay, okay, consider these positions here, right? I have to circle this, because this position. This is basically a step. Yeah, a step, which is a drastic movement, the drastic changes from the amplitude of 0 to the amplitude of -1, correct? Amplitude of 0 to amplitude of -1. And so we have learned that it is basically a special relationship between a step and an impulse function, where if you can recall back, when we have a step function, if we differentiate the step function, let's say d over dt of ut, yeah, when you refine the step function, the results will be a impulse function. Am I right? Okay, I did touch about this in the lecture number 2, if I recall back. All right. So the same things apply if the ut is said to be shifted. For example, we have d over dt. For instance, we have ut of let's say plus a, for instance. Okay, plus a, yeah. So what should be the value then? We're going to have a delta function of t plus a. Am I right?
Yes, Doctor.
Okay, good. So the same things apply if you have a negative value of the step, so we're going to have negative. Yeah? So based on that, we can apply this information to this case of differentiation of the impulse, of the step. So for this, we know that the amplitude is 1, okay, and the shifting is from the changes of the amplitude is from 0 to 1. 0 to 1, yeah? So 0 to 1 means that it will be a negative step changes. So negative step changes will result in negative impulses. So we're going to have a negative of delta t plus 1. Am I right? That should be the differentiation for these particular step functions. Right. And hopefully you understand about this, yeah? The idea is based on this relationship between the step and the impulse. Okay, now we know that this is a straight line in which the slope is equals to 1, yeah? A straight line, the slope is equals to 1. I have to write here the slope m for that line equals to 1. So when you differentiate this line, you're going to have just a straight line of amplitude of 1. Okay, just like that. Okay, that should be the results of differentiation of this slope. Yeah, that's the differentiation of this slope of 1. So we're going to have a straight line of 1. Okay, and finally, there should be another step function still here, which is a step changes from 1 to 0. Yeah, from 1 to 0, which is a negative changes, yeah, from 1 to 0. So basically for that, we're going to have another step function which will be pointing downwards also with the amplitude of 1, because the changes is from 1 to 0, so the amplitude should be 1. So that should be a negative impulses of t minus 1.
Doctor, how is it? I don't understand. How is it going down?
Okay, you have to see what should be the changes of the amplitude. So that's the
Yeah,
idea.
in the left side. In the left side, it was 0.
0 to
Then
negative
it went down. Oh, okay, okay.
Correct.
So each time it goes down, it's when we
Negative.
differentiate it, it's go down.
Negative
Okay.
amplitude. Yeah, that should be the case. Yeah? So when the amplitude is said to goes down, so it should be negative amplitude. But when the amplitude is said to be positive, means that from 0 to positive, which is increasing, so the impulse obtained will be positive. Yeah, differentiation is positive. Okay, so that should be your ZT representation. So what you have here is your ZT, which is a result of differentiation of your YT signal. So is that understood on these solutions for question number 4?
Clear, Doctor.
Okay, alhamdulillah. Very good. Thank you very much, guys. Okay, I think it's clear about this question on tutorial number 1. So any questions more on tutorial number 1? No?
I think we solved every question.
Hopefully, yeah. If you got any problems, in case you still got problems with question number 1, you can always WhatsApp me personally, yeah. Okay, so hopefully by this you are ready to face quiz 1 next week, yeah. Okay, so quiz 1 will be tested on the chapter 1. Not sure whether we're going to have it on Sunday or Monday. Just be prepared. Okay, so I think we're going to stop here. Okay, thank you very much. No, share the no. I don't have the exact solution for this tutorial questions, so I'm afraid I won't share it with you. Yeah. Right. Okay, guys. Thank you very much. I'm really appreciate your time. Okay, so
Doctor, you'll share this